Hello, this is William, and this is a brief-ish update about my Atari 2600 game, Mutatis, and some troubleshooting I'm doing regarding Scanlines. So, several weeks ago, I was pleasantly surprised when Zero-Page Homebrew with James and Tanya played the current version at that time of Mutatis on their live stream, which was exciting and really cool. And also nerve-wracking. Someone else playing your game. It's very similar to doing a table read on a new play. When someone else engages with your work, you can see it in a new light. And all of the cracks start widening, right? But that's a good thing, because then you can address new drafts or, additional coding with a new perspective and understanding. So that's cool. James was kind enough to send me an email pointing out that there were some line count issues, and so when he and Tanya played the game, you could see it vibrate or shake. So why is this? Scanlines. There's too many. The Atari's TIA chip commands the cathode ray tube television's electron beam to control the scanlines, which build every frame of gameplay. The total count of scanlines in any given NTSC frame is 525. However, NTSC 2600 games run stable when they do not exceed 262 scanlines per game frame. I'll draw 10. Of these 262, 192 are visible on screen. Non-display scanlines are in the vertical sync, vertical blank, horizontal blank, and overscan areas of the 2600 game frame. Well, the last Mutatis bin file went over this by a good amount, topping around 279. I found a web page listing different games and their scanline counts. Most commercial releases hit 262 exactly, but some are under and others run slightly over. Link in the description if you want to see the full list. In his email, James also pointed me toward Stella's debugger tools, specifically the overlay, which you can activate on a Mac with Command L. Or in Stella, go to Options and then Developer, and you'll see the toggle for Console Info Overlay. That will activate in the top left corner, and it will show you the current scanline count, followed by the hertz you're running the game at, what television system you're emulating. Here we're on NTSC, your frame rate, the speed of the game, because you can adjust the emulation speed. Shift-Control-S will slow the game down. And to speed up the game, Control-S. And this line is indicating if you're using bank switching, and if so, which bank switching format you're using, and the size of your game. By the way, during this video, you will see these two holes, kind of, in the mini-kernel. And that's because I'm using the background color of the mini-kernel as the color of the icons to hide them. But since I'm temporarily using the background color of the gameplay area as the background color of the mini-kernel, you're seeing what looks like those two little holes. Because the current level variable, which is being used as the array index for the mini-kernel's background color, is not matching the background color of the arena. Did any of that make sense? Now, when I was emulating my bin file, I didn't see any of this shake, so I had no idea this was even happening. Since James and Tanya were playing on an actual Atari, on the actual hardware, their gameplay more accurately revealed the scanline issue. But in the developer settings and the video tab of Stella, you can activate the jitter roll effect and adjust its sensitivity and recovery time. And so I was able to replicate what James and Tanya were seeing playing the game on actual hardware. What I really need to do is learn Stella's debugger and developer tools. So to start troubleshooting, I used some trial and error, which is always my first impetus, to discern how I was going over the maximum number of scanlines. At first I thought, okay, maybe it has something to do with the playfield. So I deleted the entire playfield. But the game did not like that at all. So I reinstated the playfield. And for my next attempt, I just deleted the playfield definition, retaining the playfield heights values. It played fine, but still exceeded the scanline count. Now, playfield heights is one of the kernel options available in Atari Basic, and you can use it to custom define the height of each row of the playfield blocks. Here you can see on the left they are uniform in height by default. On the right, my custom height definitions for the same playfield. So my next trial and error attempt was to leave in the playfield definition but remove the playfield height values. And that also resulted in some funky glitch art. Honestly, if I could design a game that incorporated glitches, I think that'd be cool. My next attempt, commenting out the inline code for the assembly file of my mini-kernel. You'll see the game running, no mini-kernel display on the bottom, and we're mostly close to the 262 value limit, but still running over now and then. So then I started adjusting the mini-kernel itself, and my first attempt by returning to the main bulk of the code before displaying any of the icons. And the code is close to 262 now, but upon impacts and when the Biota animation starts, it does breach the 262 value. I also momentarily commented out the Mutatis mutation, player 0 sprite, to see what effect that would have. But the game still ran hot. It was about this time I realized the PF heights values I was entering were arbitrary. Well, not exactly arbitrary. Aesthetically based on how I could get the screen to look the way I wanted, with a large gap in the center. But I was entering these values without considering a cap value. Naturally, rather than look up the answer, I just tried a random number to reduce the center value. And with that, it started running locked at 262. But the big black bar on the bottom returned from whence I had banished it. I say banished because one of the reasons I was using PF heights was to get rid of the black bar on the bottom and fill the screen with my colors. So I reinstated the witch mutation subroutine, and it still ran locked at 262. So when using playfield heights, what is the sum you must reach? Well, it's 88, and I was using 100 as the total, probably just because it's a nice round number. Why 88? Each playfield block is 8 sprite pixels tall, and there are 11 playfield blocks fully visible on screen in a Atari Basic playfield. So 8 times 11, 88. And according to Atari Age posts, you need to set the first line of playfield heights to a value of 8. And I have decided to use that line not for empty space, which looks even stranger to me, but rather as part of the facility graphic. Here's how I simplify my conception. Each frame of our Atari 2600 game is made of time. Some of that frame is for the program's calculations, and one part of the frame is used for displaying the results of those calculations. If we try to do too much of either during the time available in a single frame, the 2600 will freak. And the visual evidence of such a freak is a bounce or a roll. Even though I was setting the middle to show nothing at all, it still pushed the screen out. I don't know if I'm visualizing this correctly, but it seems even though it was empty, I was intruding on the time reserved for the overscan part of the frame. I think instead of reducing the bar, I was just hiding it. So is the bar just something you have to live with using Atari Basic? Apparently so. Looking on the forums and such. Although Stella does allow you to alter the vertical center default up and down per pixel, but this hardly seems a viable solution for consistent gameplay. And in any case, obviously I'd rather solve the aesthetic issue directly in the game ROM rather than relying on emulator settings. Okay, here are changes in this current release. First up, the most widespread change: every Y position coordinate for everything due to the new playfield heights values. A new mechanic I'm playing around with after the Eye of Mutatis has launched: you can pause flight movement. New strategies this brings into the game include waiting at a location to be hit by an enemy or to collect a biota in its path. As I play with this more, I might add a timer so you can't hold position indefinitely. An adjustment I've made to the Speedster flight path: instead of a direct and immediate attack, I was partly inspired by that drone ship from the iMagic game Atlantis. So the Speedster flies across, sort of a warning so the player can prep their shields, and then returns and attacks Mutatis. Instead of the swirl arrays for the Biota Collection, I experimented temporarily with setting the biota to follow the ball sprite's coordinates as it moves, thinking you could kind of lasso the biota into the center of the screen with your movement, but it is comically difficult. It looks kind of neat though. A lot of temporary code in this routine at the moment, but my compromise currently is the biota follows your Y position while seeking the center pillar until it gets within range and then makes a beeline for its final collection point. I decided to thin the facility graphic that I'm making with the playfield on the top and bottom. That opens up new possibilities of where enemy types can enter the screen. But it also means I have to redefine the ball boundaries. So one thing I'm doing, I'm indicating where the ball, i.e. the Eye of Mutatis, not only hits the playfield graphic, but also when it exceeds the open space, which in the manual I will be calling a repulsor field of some kind that repels the eye, so you don't cross from the top to the bottom or the bottom to the top. Instead, the eye ricochets, and during the ricochet, the eye resizes momentarily. And at first I had it bouncing back up to the center, but that was too much. So instead, it bounces up or down by a total of 20 in increments of 2 or 3 pixels, depending on the level. Another change that these new parameters led me to brainstorm is Mutatis taking damage from the enemy mutants, not just in a color change, but also being shifted on its axis. How this affects gameplay, I'm not exactly sure, but it's a little bit more visual feedback to the player. Something I discovered accidentally when adjusting certain parameters was offsetting the eye on a shield when the shield possesses the eye. It offers a cleaner read during gameplay, I think. I've also simplified the menu design, which still isn't implemented in the game. Nonetheless, I'll run you through it. So the game will start. The M is highlighted blue for Mutatis. Press the fire button. Now you get to select which game type you want to play, 1 through 4, and that will be detailed in the manual in the game select matrix. And then you will select, do you want to collect 2 biota or 4 biota in order to advance to the next level? So that will essentially be the difficulty switches. And then between levels, you will select, do you want your health on the left here to be boosted or your shield strength on the right to be boosted? Previously, between levels, your health and your shield count would just increase automatically, but now as a strategic choice, you will have to select which you prefer. After you select that, it will highlight which level you are currently on. And there are 4 glyphs to indicate that, and they will highlight the color appropriate to the background color of each level. And I also put in a proper ending when Mutatis escapes the planet if you make it past level 4, which I will withhold from showing to give you some incentive. Also, I might expand on it later if there are any bytes remaining. Here's a tip I learned during all this troubleshooting. Previously, to clear the playfield between screen switches when swapping over to the game over screen, I just filled the playfield definition with periods, indicating that pixel is off. Well, there's a command called pfclear, which I was unaware of. And using that command is not only more elegant in the code to the eye, but it saved me 31 bytes. Let's talk about weird stuff. Here's a funny thing that happened. I wanted to use the if switch reset condition to restart the game after a game over or game win, and it had a weird effect on the mini-kernel. The scanlines in the mini-kernel are now double height. I have no clue why that would be, just by using the switch reset register. And now some bugs. Sometimes the Speedster hits a shield, and instead of vanishing, it spawns a shield node, which then attacks Mutatis? I don't know. When a shield loses its last node and you immediately destroy the mutant, the explosion just pauses on the last frame of the animation, thus preventing a new enemy from spawning. And sometimes when a shield is destroyed, its missile sprite is relocated to the top right corner. And that is incorrect. And the combination of shield damage knockback and Mutatis damage knockback can lead to overlapping sprites like this. So making all these changes, I thought, like when I re-outline a novel I'm working on or a script or a play or whatever, between drafts, it really helps to realign the thought process of what's, most germane to the story you're trying to tell. Well, in Mutatis, I thought I better, in a separate document, basically outline the game using the subroutine headings and remarks as a guide to the code flow, and it made me realize how messy my code is, just how it's currently jumping all over bank to bank and back again, because I'm just, coding the game as I go, as I'm learning even how to do bank switching, and when it's best to do this routine before the draw screen command or after the game loop, where to put those routines and data arrays, etc. So what I need to do is streamline my code. Planned additions. Too many. That's it for now. You can download the current version of Mutatis on my itch page. Thanks for watching.